Hey, today we're going to talk about ionic compounds, names, and formulas. This can get quite hairy, so stick with me. Make sure you follow the directions, and we'll see what kind of questions you may have. So, we see different chemical symbols, and we think about what do they mean? What are they inferring to? Well, that's what we're going to investigate. So you've got your periodic table of elements. You need to know where the metals and nonmetals are, and generally your nonmetals are going to be throughout here, really not doing anything with the what do they call it? The noble gases. Then you also need to remember the charges based upon the patterns. So things like 1 plus for here, 2 plus for this column. Over here we've got boron and stuff at 3 plus. Generally your carbon is going to be 4 minus, nitrogen 3 minus, oxygen 2 minus, you kind of see a trend here, and fluorine at 1 minus. So make sure you do have those ideas in the columns available, because that becomes very critical when we talk about ions and charges. There's also a few in here. Zinc has a 2 plus. Cadmium also has a 2 plus. Silver has a 1 plus. These other ones can have multiple charges. So if they can have multiple charges in the middle, then we need to figure out what those are. You also have your polyatomic names. All these different polyatomic ones. These are on the back of your reference sheet, so you don't need to worry about those. You just need to be able to look them up and come to them. All right, let's see what we got. So this one's going name to formula, no metals involving things with multiple charges. So first, you got from the name determine which two ions are involved. So for example, I have sodium. So sodium with its plus charge, and sulfate, SO4 2 minus. That comes from our polyatomic. So being familiar with them and looking them up is what becomes critical. Then we want to cross the charges down from the superscript down to the subscript. And remember, this is just 1, so that would come down here. And what you need to picture is SO4 is going to remain the same. So this is Na2 SO4. Because we have the 2 from the charge of sulfate down here, and then 1 comes down here, so we leave SO4 being the same. Next one, calcium iodide. So calcium is a 2 plus charge. Iodine has a minus charge, 1. So 1 comes down here, 2 comes down here, so therefore we have Ca. Just like in math, we don't write the 1. And then iodine, the 2 came from the calcium, so CaI2. Zinc carbonate. So zinc is a transition metal, but it only has always a 2 plus charge. Carbonate is a polyatomic that you'd have on the backside, so 2 minus. We would cross the charge 2 down here, 2 down here. Now you might say, well, wait, that'll cancel out because we'll have to reduce if needed, which is correct. If you have the same charge, numerically, the number is the same, then you can put 1 of each. And say you have zinc carbonate. I'm going to do silver nitrate over here because I have some room. So silver, with its 1 plus charge, it's one of the ones that's also consistent. And nitride tells us that it's nitrogen because it ends in IDE. So that means the 3 comes down here. The 1 comes down here. So this helps us our subscript. So we get Ag3 and nitrogen with its 1, but we don't write the 1. So we're going to come back to look at scenario 2, where we're looking at name to formula with metals with multiple charges. See you then.